Now it's easy to prove geometrically if you understand a little bit of geometric proof, including geometry, high school level geometry, that if we extend each of these projection lines over to the second quadrant to where we intersect the circle, we get points that correspond to the same subdivision. Now, I haven't indicated all the points, I've only chosen a few, but if we did this for every point, the points that we get here would be at the same, would have the same y coordinates as the points that we get here. In other words, the y coordinate of the first point here, if we went over here, would be equal to the y coordinate of the last new point that we would get here. And the y coordinate of this point would be the same as the y coordinate of this point. So as we go from here to here, we would get the same y coordinates as if we went from here to here. If you think about that just a little bit, you can see that that's going to give us a graph that is completely symmetric with this one, a graph which comes back down here in a manner completely symmetric with the way this graph goes up. And without going into the details of that, which I can leave to you, we can construct the graph that we would get here without having to go all the way back to these projection lines in y coordinates, simply by the symmetry that follows from this construction. The graph on this side of the purple line, and the purple line corresponds to the line through the x coordinate, through the horizontal coordinate, that corresponds to the number of the point on this graph. In other words, the purple line corresponds to this point here, or to this angle, if you prefer. Okay. Now we reflect this graph through this line, and we don't have to go into all the details. If I want to reflect this point, let's say, well, I could start by marking an arc here and another arc here, and then I could draw arcs here and here to get the line perpendicular to the purple line through this point. And then I could mark this distance on the other side of the point. It would intersect that perpendicular line. Of course, we've already got this line. It's already been constructed. So there would be no reason to go to all that trouble, but we could do that if we want to go back really to first principles. Then, and my compass won't stretch that far, but we could mark, okay, well, not then, as an alternative, and let me illustrate it with this point. Okay. We don't even need to use this projection line. We can come to this point, mark this distance, make sure we've got it right, and then mark the same distance on the other side, and then simply mark this distance, which is pretty close to the same distance, but a little less. And, okay, this is 1, 2, 3, 4 points over here. Assuming we've got this interval subdivided, we would come over to the corresponding point here. And we get this point as the reflection of this point. And we can do the same thing for every one of these points so that we get a set of points here that are completely symmetric with respect to this line, to the corresponding points over here. Now let me point out one glaring shortcoming of the graph as I've constructed it. This distance between these points appears to be greater than the distance between these points, and the distance here seems to be greater than the distance here, and that is absolutely not what will occur. If you just think about the geometry of the circle, you'll see that the spacing between these points has to be less than the spacing between these points, which is clearly so. But then that this spacing should be less than the spacing between these points, which is not at all the way it looks. And I don't think it's the way it is. And the spacing between these points should be less than the spacing between these points. Again, it's because of the geometry of the circle. These points are all equally spaced, but this point, the segment from this point to this point is more vertical than the segment between this point and this point, which is more vertical than the segment between these 2 points, etc. And if you just take those premises and put them together, you could write out a good proof of the fact that these points, that the spacing of these points needs to be constantly decreasing. It doesn't look that way. It's very important to understand that that's the case if the graph is constructed with complete accuracy.